Today's learning target is, I will use partial products to understand how to use the standard algorithm for multiplication. Our problem of the day is, on Fun Friday, I want to reward the 17 students in this class by giving each student 15 M&Ms. How many M&Ms will I need to buy at the store? What do we know? What operation should we use? Write an equation on your paper that you think will help us solve this problem. When you're done, give me a thumbs up. Oh, Gavin already has his thumb up. Okay, Gavin, what's your equation? 17 times 15. And how do you know that? Right, 17 students, and what else? 15 M&Ms. And how did you know the operation? Because each is a multiplication word. Have we seen a problem like this before where we have two-digit factors? Yes, how did we solve it? With an area model. I remember an area model asks us to find the area of a rectangle by breaking it into smaller parts, finding the area of each of those parts, and then adding those areas together. What do we need to do to begin? Decompose our factors. Right, according to place value. So Ivy, what number would we use to represent the tens place in 17? Ivy says 1, and how about the ones place? 7. Does everyone agree? Oh, Jessie doesn't agree. Why not? 1 plus 7 equals 8. So what would you do differently? Change the 1 into a 10. And why? Because the 1 in the tens place actually represents 1 unit of 10, right? And 10 plus 7 equals 17. So Gavin, now that we've decomposed 17, how would we decompose 15 by place value? 10 plus 5. All right, and finally, we need to know how to find the area of a rectangle. Ashley, what's the formula for that? Length times width. Using what you know, I want you to find a partner, recreate the area model, and find the total area of our model, which is the same as 17 times 15. When you're done, give me a thumbs up. I see a lot of thumbs up. Ivy and Addie, what's the answer to 17 times 15? 255. How did you decide that that was the answer? Let's start with the area of this rectangle. 10 times 10 equals 100. And how did you find the area of the next rectangle? 10 times 7 equals 70. And how about this rectangle? 5 times 10 equals 50. And finally, how did you find the area of this rectangle? 5 times 7 equals 35. Are we done? No. 100, 70, 50, and 35 are what we call partial products. We broke apart our factors into parts, multiplied those parts, and now we need to add the products up to get the final product. Now, how can we add these products up? Addie's saying add across. So 100 plus 70 equals what? Shout it out. 170. And 50 plus 35. Shout out that answer. 85. Are we done? Oh, Jessie says we need to add these two together. So if we add 170 plus 85, we get 255. Now there's one more way that we can check Ivy and Addie's work using partial products. We can rewrite our equation as 17 times 15. Now we're going to use our area model to figure out how to solve this equation with partial products. Now we know the partial products, we're breaking up our factors into parts. We're going to go according to place value again. So we're going to start by multiplying the numbers on the ones places. 5 times 7. Did we do that before? Yes, 5 times 7 equals 35. Now we need to multiply the number in the ones place in the second factor by the number in the tens place in the first factor. Did we do that before? Yes, we know that this is actually 5 times 10 equals 50. Now, where can we go from here? Oh, I heard someone say that we need to multiply the tens place in the second factor by the ones place in the first factor. That's right. We know that this is actually 10 times 7 equals 70. So, Jessie, what's left? 10 times 10. How did you know that? And because it's the final box in our rectangle, that's correct. But what does it represent? The tens place times the tens place. So 10 times 10 equals 100. These are the same partial products we had before. 100, 70, 50, and 35. We need to add them up, and we get the same answer, 255. Ivy and Addie's work checks out. There's an even faster way to solve multiplication equations, and that's by using the standard algorithm. Again, we're going to write out 17 times 15, and we're going to multiply while keeping place value in mind. So again, just like with partial products, we're going to multiply the digit in the ones place of the second factor by the digit in the ones place of the first factor. So that's 5 times 7. Now, what did we determine that was when we did our area model? 35, right, Gavin? So right now we're only going to write down the number in the ones place of our answer. So Ashley, what's that number? 5. Very good. And we're going to carry the 3 over, the 3 from the tens place of our answer over to the tens place when we multiply 5 times 1. That's actually 5 times 10, right? The 1 is in the tens place. So we're going to carry the 3 over to this section. What we essentially just did was turn 35 into 30 plus 5, and we regrouped. We added the 30 to this section. 5 times 10 is 50 plus 30, the 3's in the tens space, equals 80. So we have 85. 5 times 17 is 85. Now we need to move over to the tens place of our second factor. So is this really a 1, Ivy? No, it's actually a 10, right? We're going to multiply the tens place of our second factor by the ones place of our first factor. That's 10 times 7 equals 70. And then what do we have left? Gavin's saying 1 times 1. Is that really 1 times 1 though, Gavin? Can you get rid of that 3? No, it's really 10 times 10, right? Just like we did over here. 10 times 10 is 100. We're going to add 85 and 170. Did we see those numbers before? Yes, when we added up our partial products with our area model. And our answer is still 255 M&Ms. Now, if you understood the standard algorithm, I want you to give me a thumbs up. If you feel like you could use some more help tomorrow, give me a thumbs down. Oh, we've got a mix. We'll be reviewing partial products and the standard algorithm again tomorrow in small groups.